All right, guys, so I got the two printers running a couple of jobs here, and you hear that clicking? So that clicking is an indication that there's trouble that's starting with the filament flowing through the nozzle. So once these prints are done, these two printers are going to need some maintenance, and I'll show you what we're going to do to fix this problem. First thing we need to do is to protect our build surface, or remove it. Remove the cover of your fan shroud. And remove the silicone sock. And what we want to do next is preheat the hot end. It doesn't have to be blazing hot. I like to preheat it to about 160, and that is enough to loosen any material that I might have, making it easier to remove the nozzle. Also at this step, remove the filament so that there's no filament inside the hot end before we disassemble it. Next, grab yourself some a crescent wrench and grab the heater block, and then use either one of the wrenches that comes with the kit. Break the nozzle loose, and then be careful because this nozzle is going to be hot. Now use your wrench and remove the pneumatic fitting. Sometimes you can get the bowden tube out without removing the fitting, but sometimes the bowden tube gets stuck, like in my case. I just had to remove the whole fitting and just put it out of the way. And I used a fix that I found online from Chuck's channel called Chep, and he puts out a video called Filament Friday, and he had this neat little fix here to put pressure on the bowden tube up against the hot end, and it worked well for a while. I did come across another version of this that I found was a little bit better, so I'm going to try that next. Now we're going to remove the heater, so just use the little grub screw to remove the heater. Remove the two little screws that hold the heat block to the heat sink, and then remove the heat break out of the way. So you can see here, this there's a filament that melted between the PTFE tube and the nozzle, so that's what was causing our problem. That stuff starts to solidify and it gets to the point where it doesn't flow anymore. And if it's stuck like it is for me here, I couldn't get it out by just pushing it out. So what I'm going to do is I'm going to get a heat gun, heat the thing up, and push the section of PTFE tube out of there. Now these are the parts of the hot end. Starting on the left side, you got your pneumatic coupler. Then we have the heat sink along with the heat break, and this is a PTFE heat break. The heater block, the screws that hold the heater block to the heat sink, and the nozzle. And the way this fix works is typically the PTFE tube is held completely in place and up against the hot end using these little teeth that are inside of this pneumatic coupler, and really that's it. But over time, as the printer is running, this PTFE tube will start to move a little bit as those teeth dig in from just the filament retracting and being extruded out of the PTFE tube. This tube will start to move a little, and as it moves, it opens up and creates a leak between the PTFE tube and the nozzle. So I found it very interesting when I saw Chuck's video on his channel, Chep, address this, and he didn't come up with it. Yeah, he found it on somebody else. It might have been a Thingiverse file, and someone came up with a solution. And once I saw it, I knew that that was the answer to resolving this problem. And the reason that it didn't work out for me the first go around is because I noticed the PTFE tube was too short. So what I came up with is a remix of a jig that I found on Thingiverse. But this is the original little spacer from Chuck's channel. And how it works is it drops down inside of this bore here where the pneumatic fitting goes and lands on that first ledge. And the way it works is the pneumatic fitting puts pressure on this washer, and then the PTFE tube slides inside of the heat break and is sandwiched between the washer and the nozzle. And that's the way it's supposed to work. But I'll show you what happened in my case this first time that I did it. When I put this heat break in here, you'll see that the PTFE tube doesn't protrude past the threads, and so I had a leak right from the beginning, and that's the reason why I'm having to fix it again now. But what we're going to do is I'm going to create a little jig that's going to make it a consistent cut every time. So I did a quick Thingiverse search for more fixes like this. And one of the challenges is to cut the PTFE tube perfectly straight. And I picked up this Capricorn kit that came with this little cutter here, and it works really well. The only thing that I didn't like about it is it relies on you taking measurements and marking the PTFE tube and then trying to line it up just right with that cutter before cutting it. But there was a lot of cool solutions on Thingiverse on making a little bit like a little plastic jig to hold the PTFE tube, and I thought it was really awesome. I came across a bunch of different designs, but the one that I liked the best was this one that really gripped the PTFE tube really well. And once I determined what the proper length was needed for my particular application, and this is on a Ender 3 V2, I created a jig. But this is the jig I got from Thingiverse. But the problem with it is the opening for the razor was too small, and the PTFE tube wouldn't fit. It was too tight. So I'm not sure if maybe it was the way the settings are on my printer or what the issue was, but I couldn't get this PTFE tube to go in here. But I really like the design. It's very well thought out. And what I did is I jumped on Onshape and just remade this part. I made a couple little tweaks to it to enable removing the tube to be a little bit easier. So here's the remixed version. And now this one is a little bit bigger. The PTFE tube slides right in there. And a razor, standard utility knife razor, fits in that slot. You can see it's like a little miniature guillotine. So now the other part to this little Bowden tube jig is it came with a little collar similar to the one that I got from Chuck's channel. And before we put this little collar on, we need to make sure we got a straight end on our PTFE tube. So all I'm doing here is I'm just straightening it out a little bit, so that when we remove it from the jig, it will have a nice straight little piece. And we want to start by cutting a flat end. And it's already flat, but I'm just going to demonstrate it. I'll cut it again just so you guys can see. And I'll include the STL file for the remixed versions along with the credit for the original designers in the description. So all you got to do is just put the end that you want to cut into the little jig. And since we're cutting only the end, I don't have to push it all the way in. And then just line it up inside the little slot and just push down. So now we got a nice, clean, flat, straight cut. And I found that one of the Allen keys that comes with the Ender 3V2 fits in here pretty well. So I'm just using that to push that little piece of tube out of there. And now that we got one flat end, what we can do next is insert the PTFE tube section into the jig and cut the piece that we're going to use in the installation. So this is about just under 31 millimeters. It'll give us a Bowden tube section just under 31 millimeters. And this is what I found works for me. Now, I'm not sure if all of these hot ends are machined the same, but this is the size that worked for me in this one machine. If you need it to be a little bit longer, a little bit shorter, it can be resized in Cura. Just resize only the one axis that needs to be resized so that the other dimensions don't change. But this little slot here on the back allows you to push the little tube out using the flathead that came with your kit. And so now we got a nice flat piece of PTFE tube that we can use here in our new hot end fix. So the original washer did have a hole and it did have a taper, but the problem is it allows the Bowden tube to shift around. So if it's not perfectly aligned, your filament may get stuck when it's being replaced. But this one that I found that came along with this little jig worked really well, but the original one was too small. So this is the original one here, and again the PTFE tube did not go in. So I just remade the part in Onshape and just opened up that that hole a little bit wider so that the PTFE tube would just push inside. And this is it right here. So all you got to do is just turn the PTFE tube face down, drop it inside of there, and then put the pneumatic fitting on top. And I gave mine kind of like a hand tight because that's really all I needed. It'll get real tight once you lock it all in. But you see now how the sleeve, the heat brake, slips over and that PTFE tube sticks out just a little bit. Sticks out about 3/4 of a millimeter. And I'm going to go ahead and cinch down this grub screw. And it doesn't have to be crazy tight, just tight enough that that sleeve is not going to come out of there. Next up is to reinstall the heat block. And I'm turning that heat block till it's all the threads are pretty much taken up. And then I have maybe about 3 millimeters to 4 millimeters of thread at the bottom for the nozzle to go in. I'm tightening these screws a little bit at a time. I don't want to over tighten any one side, so just tighten till you start to snug up one side and then just evenly go back and forth, progressively tightening a little bit more each time. And again, these don't have to be crazy tight. You just want it tight enough that it's not going to rotate once you start to put your nozzle on. And we're also going to be holding the heat block with the crescent wrench, so it shouldn't move too much. So these don't have to be the only thing holding the heat block to the heat sink. So it'll be a combination of pressure from the nozzle to the heat brake, and then these two screws to aid in the lateral movement. So this is the one thing that the all-metal hot end does not have. And I understand the reason they didn't do it. They don't have these screws is to avoid heat creep. But what I've had happen to me a couple times already is the heat block, for some reason, even though it's been torqued properly to the heat brake, the heat block will come loose from the heat brake because the only thing keeping it from rotating it is the threads on the heat brake. So this design works really good. And then I'll include the link to this cool little tool that I found on Thingiverse. A very creative guy made this. It's a 3D printed torque wrench, and it comes with different diameter fins that you can install on the inside to get different torque ratings. I'm using the heaviest one, which is a 1.25 millimeter thickness, and it works great. So I'll show you how it works when we tighten this thing up. But now the next thing to check is to make sure that there's no problems feeding the filament into the hot end. So what I'm going to do is I'm going to grab a little piece of filament and push it down through the pneumatic coupler, through that little collar, the plastic collar, down the PTFE tube, and into the nozzle. And I'm going to check to make sure that it's gone all the way down, is to stick the little acupuncture needle, the 4 millimeter needle that comes with your 3D printer. I'm just going to poke that into the tip here. And it shouldn't go in at all because I got the filament right there. If I can push it inside of that hole, then that tells me that the filament is not all the way down there yet, and it might have got hung up on something. And this is what you want to make sure, that you don't have problems feeding the filament down, because when you do a filament change, that's when you'll notice that you have the problem. So I'm just double checking here. I'm just going to push the filament, and if the filament pushes the pin out, then I know that nothing is interfering with the filament. And there it is. So pop right out. And then I'm going to pull the tip off so you guys can see how far down that filament goes into the nozzle. It's literally right there at the very tip. So making sure here it's all the way down. And you can see it's all the way down. And just double check it and make sure that it moves nice and smooth. Make sure that the heat block is nice and flat, nice and straight. Assembling it on a flat surface helps. Now we're just going to reinstall the hot end back to the carriage. And it's got a couple of lock washers, so all you got to do is just tighten it up. Reinstall the heater cartridge and the thermistor. Now grab your crescent wrench, and then I'll show you how awesome this little torque tool works. So just tighten it up until it clicks. Reinstall your bowden tube. And if your bowden tube has got like a severe ring worn from the little jaws that hold it, you can always cut the tip of it about a 1/4 inch so that the little jaws are grabbing some new PTFE tube. And now we're just going to reinstall our fan assembly. So the Ender 3V2's got one single screw that holds it, and I'm just pushing the little sock down. Make sure you put the silicone sleeve on there before you tighten it down. I'm just reinstalling here the Creality build plate. And if you guys haven't seen that video, check that one out. This Creality is fantastic, at least for working with PTEG. It sticks to it like crazy. It releases really easy once it's cool. It's awesome, and it's not very expensive. I want to say it was like 25 bucks shipped, which is a bargain compared to some of those other build plates that are out there, and it works a lot better. So now what I'm doing here is I've inserted the filament almost all the way down, and I'm just going to put the acupuncture needle back inside the hot end. So I'm just pushing it up through the nozzle, and how I know that the filament is all the way down is it'll push it out, and once it pushes it out, then I know I'm good to go. Then I don't have anything that's hanging up the filament from the bowden tube all the way down into the nozzle. So I'm just feeding it in slowly, and you'll see that acupuncture needle pop out of there. See, there it goes. So that's it. Now what we're going to do next is preheat the hot end, and we're going to check to make sure that we get good extrusion. So if you're running the Gyros UI, just run over to your movement, set your extrude to 50, and just extrude some filament. And when your filament starts to come out, it should come straight down. If it starts to do a bunch of curling at the tip and it's not flowing straight down, you got some kind of a problem in there. And that's what mine was doing prior to me taking it apart. So you can see you got good flow, and it's coming straight down. And the curling at the bottom is just because it's hitting the build plate already, so it's just swirling around. But you can see it's a nice, steady, consistent flow of filament. Next thing we got to do, since we already made some changes to this, we're going to have to check our leveling. What we're going to do now is to home everything. So we're going to home all. And now we're going to check our Z. So we did change the nozzle, so we are going to have to play with our Z offset. We just need to see how far off it is, so that when we start making our adjustments, we're not crashing into the bed. So what I did here is I was able to get it down to 0.1. But if I got it down to anything, if I got it down to 0, it was going to hit the bed. So what I did is we needed to create a new mesh so that we can get ready for our first test print. So we're going to create a new mesh, let it auto level. And then my original Z offset was 0.99, and I was about 0.10 too low, which means I had to raise my Z offset to about 0.90. So that's what I did. So right now I'm getting my build plate centered. So I set my X to 150, my Y to 150, and that puts my tip right in the middle. Now what I'm going to do next is bring down the Z again. And we'll try 0.5 and see where we are. Okay. And then I'm going to put my feeler gauge down here. This is a 0.10 feeler gauge. And I'm going to keep lowering down the Z until it hits that feeler gauge. So right here it's still, I could still move it. That's at 0.3. Now I want to drop it to 0.2. And at 0.2 it still moves. I'm going to drop it to 0.1. And now at 0.1 it's starting to drag on the feeler gauge. So I know that if I go to 0, it's going to be touching the bed, which is not what I want, because then it won't extrude. So I need to change my Z offset. So I have already set my Z offset to negative 0.90 from its original negative 0.99. And what we're going to do now is we're going to do a test print. So I have this print in the description if you guys want. It's a 6 square bed adhesion test. And it's going to, 9 squares. So it's going to print out 9 squares. And as each square progresses, what I do is I change my Z offset based on what my observations are on the way the current square is looking. So right now it's going through its auto bed leveling routine. And I got a pretty cool G code that I found from a forum that I tweaked to work on the Ender 3 V2. I'll leave that in the description. If you guys want to use it, it's pretty cool. It preheats the hot end, not so hot while it's doing its probing that it's going to ooze filament, but just hot enough to get it close to melting the filament. And when it starts to do its purge, it purges right along the same edge where the printer head was parked. So it's not going to ooze filament all over your build plate going across from the right side to the leftmost corner. So I'm starting this first square is 0.90. And what I made is a little sheet of paper with the 9 squares written on it. And as it goes, I write in the Z offset for that particular square. So that then later on I can go and look at the squares and see which is the best one. So right before it finishes, I'm going to change the Z offset. So right now it's at negative 0.90. I'm going to go in here and get it ready to change to negative 0.89. And right as it goes to the next square, I go ahead and I hit the button, and now it's a little bit lower, actually a little bit higher. So my goal here is to get as close, as far away from the bed with the print tip, with the nozzle, but still maintaining good adhesion. Because what you don't want is you don't want the nozzle dragging through the filament. Because when it does that, it starts to pick up filament along the edges and you get excessive stringing. So again, right before it switches, I go ahead and I punch in my new Z offset, mark it down on my sheet of paper, and then wait for the next square to complete, and just repeat the process 9 times. So you can see there is negative 0.87. And when these numbers are negative numbers, the lower the negative number is, the higher up you are off the build plate. So what we're doing now is just inspecting these squares. And you can see the first ones that printed, the 0.90 and the minus 0.89, they got strings on top, and that's because the print nozzle was too close to the bed. So it was squishing the filament, and as it was passing across, it was digging into it and melting it, and that causes the filament to stick to the edges of the nozzle, and it creates a stringing. So there's no amount of retraction that's going to fix this. This is just settings. So once you set the proper distance, you won't have these problems. You'll have good adhesion, no stringing, and once it's set properly, then you're good to go. All right, so after we ran our test, this is the results. On the previous segment, I showed you the ones that had the stringing, and as you went along, the idea is to make notes on a blank sheet of paper. Let's see if I can grab this thing out of here. It's kind of small. So this one, if we inspect this one, we can see that it's got some stringing. And the reason that it has this stringing is because the tip is too low, and it's dragging along the filament that it's pushing out, and that causes that filament to stick to the edges of the nozzle, and it'll cause additional stringing. So if your nozzle height is too low, despite having perfect retraction settings, you're still going to have stringing because of this. So what I like to do is have the nozzle as high as possible, still maintain good adhesion to the build surface, but eliminate completely the chances of this stringing occurring. So this is at negative 0.90 on the Z offset. And then we can see the other ones that also have stringing. I think this was the next one that followed it. Yeah. So this one's 0.89. So again, you see that stringing there. And that's all I do. I just keep, every time it goes to a new square, I'll go ahead and I'll change the Z offset, and I'll raise it slightly or lower it depending on what I see, and until I get it right. When you get to the point that you start to be able to see through the square, see right now you can't really see through the square. The square is pretty much solid. That means you got good adhesion. There's no separation between the different paths of the filament. So now I'm going to skip over here to the last one. So this one was a negative 0.82, and you can see there is no stringing, but what you do have is you're starting to see holes in your print. So this is almost perfect, almost, but you're up too high. So the next thing would be to drop it down a little bit more. So if we look here, this is negative 0.83 and negative 0.83. It looks really good, but you got a hole right there. So now this hole could have been from some filament that was dragged over from the previous segments where it had developed filament along the edges. But the one that I think looks the best is the negative 0.84. So if you look at this one, you got no stringing, there's no holes, and yeah, it looks great. You got good line detail when you look at it from the back. You can see the details of the lines are not all totally smooshed together that you can't see any of the bead details. And I'll show you an example of one that is way too high. I got one here somewhere. So this one. So here's an example. This one was a Z of 0.78. And you can see right through. You don't have good. See the strands are completely separated. So this is an example of it being way too high. And what happens if you have it too low, for example, like on this, let's go to this one here. So if you have it too low, like in this first square that was printed out, and you got the stringing and the nozzles going down and it's picking up filament as it goes along the edges, your brims are going to be very difficult to take off. So if you're printing with a brim, your brim is not going to be any different than this first layer. It's going to be real difficult to remove, and that's because you're getting too much squish. The tip is pushing down too hard on the filament, spreading it out too much, and your brim is not going to be easy to remove. Once you have it set properly, though, like this, your brim will be easy to remove. And I'll go ahead and I'll print something that has a brim so you guys can see. But yeah, this is perfect. So what you want to do at this stage is go into your menu. So we're going to go to our menu here. We're going to go to, oh, it was right there, Z offset. And we're going to change this to negative 0.84, which in my case was the best one based on how everything is set right now. So you want to select it, and then you want to save it. So you're going to go down here to where it says save, and it'll beep, and it says settings stored. If you don't do this step and you restart the machine, it'll default back to whatever it was prior to you making these changes, and your settings will be off. This is our first test print that uses a brim, and if we got our settings right, the brim should be easy to remove from the part. As you can see, yes, it is. If you're too close to the build plate with the nozzle, you'll have stringing, and then another sign will be your brim will be difficult to remove. Now, I got my brim and raft flow rate at 77%, and that's what works well for me. This number can be tweaked even lower, so you can have it at 0.60% or 50%. But if you're at like the between 70 and 80% and your brim is not coming off easily, it might be a sign that you're too close to the build plate with your nozzle. All right, guys, if you like the content I'm putting out, make sure to subscribe to the channel if you're new. Turn on your notification bell. That way you guys know when I put out new content. Leave me some comments. Share this video with your buddies. Until next time, God bless.